Hello everyone, today we're going to talk about section 3.6, talk about different types of triangles. First off, we're going to talk about classifying the different triangles by their side names and their angle names. Talk about different ways for each one. And then we're going to talk about using the isosceles triangle within our proofs. There are two different ways to name triangles. We'll go over the different length of the side names based off of their lengths of sides, and then based off of their angles. And then something that we've already talked about, make sure we need to know, is that all the angles in a triangle add up to 180 degrees. Because you have to do some writing on this one, but when you're classifying triangles according to their sides, you have three different names. The first one is a scalene triangle, and a scalene triangle is a triangle that has no sides that are congruent. An isosceles triangle is a triangle that has at least two of the sides congruent, and specifically the legs that are the congruent sides in a triangle, and then you have the remaining side is the base, and then the two base angles. So in a proof it might say that it's an isosceles triangle given a specific base, which tells you that the other two sides are congruent, or it might tell you that it has these two sides as legs, which tells you that those are the two sides that are congruent. An equilateral triangle is a triangle that has all of these sides are congruent. So if we were to say classify a triangle based off of its sides, you would have to list one of these three descriptions for the description based on the sides. We could also class triangles according to their angles, and there are four different ways we can classify triangles based on their angles. The first one is a right triangle, where specifically it has one right angle. In this case, that is the right angle. And then something that we should all be aware about, once we have a right triangle, that the side opposite the right angle is called the hypotenuse, and the two remaining sides are the legs. We could also have a triangle called an obtuse triangle, and that is a triangle that specifically has one obtuse angle. And in both the right triangle and an obtuse triangle, because the angles have to add up to 180 degrees, you can only have one right angle or one obtuse angle. The description for an acute triangle is a triangle that has all of the angles that are acute. So all angles in the triangle are less than 90 degrees. And the last one is an equiangular triangle, which has all of the angles whose measures are the same, which would mean that they would also have to be 60 degrees. Now, if a triangle is equilateral based off of its sides, it would also be equiangular based off of its angles, but you have to make sure that you list it according to the different descriptions. If it says listed by its sides, you have to choose one of those three words, and if it says by its angles, choose one of these four words. There's a couple different things we can do based off of these. First off, we could classify them, and then we could also use them in proofs. So in this first example, we're going to need to solve for x and classify the triangle based off of its side name and its angle name. Why don't you first pause the video and solve for x. So first off, you can add them all up, all the angles up, and set equal to 180, and then solve for x, and we get an x value of 8. We can then plug that x value back in and find out that the angle measure here is 63, and the angle measure here is 54 degrees. So we first found our x value, and then we can go through and find the different names. First off, the side name, because we have two sides that are marked congruent, we can call this triangle an isosceles triangle. And then looking at the angle measures, all of the angles in here are acute, which means that it is an acute triangle. Now, how does this look in our proofs? As we stated before, it would be helpful when you're looking at these proofs to first figure out what you're going to do before you actually start listing down all the steps. So in this first given, we have that the triangle is isosceles with the base of BC, which means that these two sides are the leg of triangle ABC, the legs of triangle ABC. We could say that those two sides are congruent. Based off of the second given that D is the midpoint of BC, we know that the midpoint divides it into two congruent segments. Looking at the prove statement, we want to get that these two angles are going to be congruent. And those two angles look like they are in the two separate triangles, and we have two pieces of information on each side. And we could use the third side to get the triangles congruent. So now we need to list that in our proof. So if we start off at the very beginning, first off that the triangle is isosceles, and that told us that we had two sides congruent. If a triangle is isosceles, then the two legs are congruent. We then brought in our next given, and as we stated before, we said that the midpoint, if a point is a midpoint of a segment, then it divides the segment into two congruent segments, and that gave us another pair of sides in our two triangles. Then we were missing a third piece of information to prove the triangle is congruent, and that was that we had a reflexive side. Now have all the pieces necessary to prove the triangles are congruent. And it's by side, side, side. And then we can say that the angles are congruent by CPCTC. Moving on to the next one, it's talking about proving isosceles this time. So in order to prove a triangle is isosceles, we need to get two sides are congruent. So if we look at our given information, we first know that we have perpendicular. Perpendicular is going to end up telling us that we have a pair of right angles. We also are given that AD, ray AD, bisects angle BAC, which tells us that those two angles are congruent. So now again, looking at the two separate triangles, we are missing a side in the middle, and we could prove the triangles are congruent, which would in turn give us these two corresponding sides, which are sides of the triangle. So first off, starting with perpendicular, it tells us that we have a pair of right angles, because if two segments are perpendicular, then they intersect, forming right angles. Common mistake here is that people like to put the angle next to it and say that this is a corresponding, that this is a piece of information, but that is not true, because in order to have that corresponding statement, we need to have a congruent statement. We need to say that those two angles that we just said were right are congruent to each other. Now that gave us an angle. We take our next given information. We said that if a ray bisects an angle, then it divides it into two congruent angles, and that gave us another angle. We are missing our next piece of information, which was the reflexive side. Now if we look along the side here, we are not using angle, angle, side to prove the triangles are congruent, because if you look in our diagram, we have angle, side, angle. So we just have to make sure when we list the triangles congruent, we base it off of the information that we're using in our diagram. And then we need to say that two sides are congruent based off of the triangles being congruent by CPCTC. And the reason why we wanted those two sides in the very beginning is that those are two sides of the bigger triangle, which tells us that the triangle is isosceles. because if two sides of a triangle are congruent, then the triangle is isosceles. Go ahead and take a minute and solve proof number 3, and when you are done, you can check your answers. Okay, we'll check our answers for number 3. Now, we need to be very careful that we double check our if-thens for altitude and median. So first off, we start with altitude, and that would give us that two angles are right angles. If a segment is an altitude, then it goes from the vertex to the opposite side. We really need to make sure that we have vertex and opposite side forming the right angles. And as we stated in the last proof, we need to state that the angles are congruent. With our next given of median, if a segment is a median, then it goes from the vertex to the opposite side, dividing the side into two congruent segments. We then have our reflexive side. So if we look in our diagram now, we have enough information to prove the triangles are congruent by side angle side. And because we want to get the triangle isosceles, we need to get two sides of that triangle congruent. And we now can do that with CP/CTC. And then state the triangle is isosceles. Go ahead and complete proof number 4 for tomorrow. We'll check number 4 when you get into class, and this concludes section 3.6.